Welcome to the Teamcenter integration for SolidWorks. First, a brief overview of the user interface. The integration is loaded as a SolidWorks add-in, making all functionality available from within SolidWorks. The first tab displays information about the active model. The second tab displays the contents of the cache. Here you will find many options to organize your view of the SolidWorks data. The third tab gives you full access to Teamcenter PLM, including workflows, visualization, bill of materials configuration, and much more. Finally, there is a Teamcenter ribbon bar, for quick access to the most commonly used functions. Now let's look at a simple mechanical design workflow. A design engineer is assigned a task to replace some fasteners in a lower-level subassembly. The task appears in his Teamcenter inbox. He wants to make the change in a copy of the subassembly, and to update its parent assemblies to reference the copy. Hosted Active Workspace provides access to all needed PLM functionality, without ever leaving the SolidWorks session. The designer performs a where-used search in Teamcenter, to find and load the top-level assembly into session, so that it is automatically modified as the target design changes. Now that all required models are available in the SolidWorks session, the subassembly may be copied. The user has the choice to create an independent copy, a replacement copy, or an occurrence-specific replacement copy. In this case, he will replace both occurrences of the subassembly with its copy. Now the subassembly replica can be modified without affecting the original model. The Teamcenter integration supports tri-directional cross-highlighting between the SolidWorks feature tree, the graphics window, and the Teamcenter panel, making it easy to identify models of interest. Here the user is replacing all occurrences of a bolt with a substitute from Teamcenter. The Teamcenter integration detects the pending modification, and prompts the user to check out the model before continuing. This is important protection against making local changes that cannot be saved to Teamcenter. Watch closely and you will see the bolts become shorter in length. Now let's see what has happened to the modified model's parent assemblies, and how the integration tracks local changes. The change was made directly to the mounting bracket subassembly, and it, as well as its parents, is marked as modified. The user is ready to save his changes to Teamcenter. But first, he wants to ensure that nothing else has changed in a way that would affect his modifications. Teamcenter notifies him that several referenced models have indeed been changed by someone else. With a single mouse click, he can update his session to incorporate changes made by others. Watch carefully, and you will see the height of the table mechanism become lower. A drawing is now created for the top-level assembly. Best practice is to immediately manage the drawing in Teamcenter, by assigning all required properties. The integration guides the user as the drawing views are placed. Annotations are now added. Find numbers from the assembly's Teamcenter bill of materials were mapped to the assembly feature tree when it was opened, and these are now used as balloon notes on the drawing view. Let's recap. First, a copy of the subassembly was made and changed, in the context of its parent assemblies. Next, changes made by others were detected and merged into the SolidWorks session. A new drawing was created and its annotations were populated with mapped Teamcenter values. Now it's time to save all these changes to Teamcenter. During save, 2D and 3D lightweight visualization files may be automatically translated and made available to non-SolidWorks users. Here we see that a user, working only in Teamcenter, is able to review the design changes made in SolidWorks. He can view the attached PDF created from the drawing. He can also view the 3D rendering of the configured assembly, and perform measurements, cross-sectioning, and more.